Alrighty guys, we're going to be reviewing factoring methods. This is essential to be able to succeed in section 8.1. So let's begin. They would like us to factor this binomial, and of course the many different factoring methods that we know, we always need to start with that first method of pulling out the GCF. So is there something in common with the 3 and the 6? Absolutely, the multiple of 3. So if you were to pull out the multiple of 3, what would be left in here? Well, it's kind of like a reverse distributive property where you think 3 times what gets you back to the 3x? Well, that'll obviously be an x. And then 3 times what will get you back to a 6? That'll obviously be a positive 2. And that's what factoring is, and that's what you need to type in to get full credit. As you can see, it's right there, 3 parentheses x plus 2, no spaces between your terms, and you'll get the correct answer. Let's move on. They want us to factor this quadratic trinomial, and I hope we remember that when you don't have a number out here, when there's a 1 as the a value, it's really beautiful to factor because you could simply jump right into the factored form format of the parentheses with the x and x. Why is that? Because we know that x times x will get us the x squared. Now if you had a 6 right here or like an 8, like let's say you had an 8 right here, then it wouldn't be x times x. You would have to have like a 2x and a 4x, or maybe a 8x and a 1x, and you can't do the method that we're about to do. So what method am I talking about? I'm talking about thinking of the multiples of the c value, negative 32, that if you combine together give you the b value, negative 14. And you might want to make a list. I always do. How could you get the c value of negative 32? Well, you could get negative 32 by doing negative 1 times 32. And then negative 2 times what? Well, what's half of 32? That's 16. Negative 3 will not work. Negative 4 times something give you a negative 32. Negative 4 times 8. Negative 5 times something give you a negative 32. No, that won't work. Negative 6, nope. Negative 7, nope. Until you get back to negative 8, but you already did the 8 and the 4, so it'd be pointless to continue. So these are the only 3 possible options that'll give us the answer negative 32 when we multiply. So the question is, which of these pair of numbers combines together to give us the b value, which is negative 14? And if you think 32 take away 1, that's 31. That's not 31. 16 take away 2, that's 14. That is 14, but it's not exactly 14. There's a minus sign in front of it. So we do have the right numbers. We just have the wrong signs on those numbers. Okay, because 16 minus 2 is positive 14, not negative 14. But it is 14. So again, this is the pair of numbers that we want, but all we have to do is change the signs. And now, negative 16 plus 2, that will give us the negative 14 in the middle. Once again, the thought process is to set this up and then think what times what is the last number that if you combine together gives you the middle number. And that will be a positive 2 and a negative 16, and that's the correct factored form. If you wanted to double check it, just distribute, and then combine like terms in the middle, and you should get to that original variable expression. Let's move on. As you can see, the answer is right there, x minus 16, x plus 2, and it doesn't matter which order you write it in, it's going to be correct. So if you were to switch the order, you'd still get full credit. Let's move on to the next question. Another ridiculously easy question. Why is that? Because the a value is 1, and you could simply think what times what is the last number, the c value, that if you combine together is the b value, the middle value. Okay, so what times what is negative 6? I always like to just make a list of numbers and start with negative 1 times 6, negative 2 times 3, and that's about it. Now, which pair of numbers gives us the middle term, negative 5, when we combine them? So 6 minus 1, that's 5. And that's 5, but I want it to be a negative 5. So I have the right number, just the wrong sign. So I have the right numbers, just the wrong signs. So this is the pair of numbers I want. So change this to a plus 1, change that to a minus 6, and you're good to go. Plus 1, minus 6. Now some of us might be thinking, wait a minute, 2 plus 3 is 5. No, you're not adding 2 plus 3 right here. It's negative 2 plus 3, that's 1, and that middle value is not 1, right? So this is the correct combo, positive 1, negative 6, and that's factoring. Let's move on. We finally get to some fun stuff here because the a value is not 1, and we have to use that longer multi-step process of factoring. Maybe. The reason why I say maybe is because before trying any method of factoring, the very first type of method of factoring that we learned was pulling out the GCF. So always try that first method. Okay, so there is a multiple of 4 here, multiple of 4 there, and a multiple of 4 there. So you could factor out a multiple of 4. So pull out the GCF of 4, and that's it. Now, there are no x's in all 3 terms, so it's just the multiple of 4 that you're pulling out. So if you do pull out that GCF of 4, what's going to be left over on the inside? Well, 4 times what will get you back to a 4x squared? 4 times x squared will get you back to the 4x squared. Okay? 4 times what will get you back to a minus 4x? 4 times minus 1x will get you back to a minus 4x. 4 times what will get you back to a minus 24? 4 times minus 6 will get you back to a minus 24. And ladies and gentlemen, we have factored out the GCF. Okay? Now, you got to look at the inside of the parentheses and see if you could continue factoring. So we're going to kind of ignore or only focus in on the blue quadratic trinomial right there. And if you look at the blue quadratic trinomial, x squared minus 1x minus 6, there is no number in front of the x, which means that you could possibly factor it even further, right? Thinking what times what is the c value of negative 6, that if you combine is the b value negative 1. Okay, and again, you might want to make a list, right? I want to make a list of the c values, so the multiples of that c value, negative 1 times 6, negative 2 times 3. Now, which of these pair of numbers combines together to give us a negative 1? Well, if I combine this, that'll give me 5, and that's definitely not a 5. If I combine this, it'll give me a 1, and that is a 1, but it's a negative 1, so I have the right number, just the wrong sign. I have the right numbers, just the wrong signs. So go ahead and change those signs, and now you have the right pair of numbers. So inside, you're going to put the plus 2 right here, and you're going to put the minus 3 right there, and that is now factored. So this blue quadratic trinomial is now factored as this binomial times this binomial. What about the outside 4, that GCF that you originally pulled out? Simply bring that down, and here is your completely factored form of this problem. Okay, I hope this helps. So, yeah, let's move on. Okay, finally a fun one. And there's another one where the a value is not 1, but you can't pull out a GCF. You can't pull out a 2 from here, here, and there. You can't pull out a 3 from all these, so there is no GCF to pull out. But that's the first thing you're supposed to always try. Always try to pull out the GCF. There is no GCF. Okay, so what do we do next? This is finally that type of question where you do that multi-step process of factoring when your a value is not 1. Step 1 is to multiply a times c, okay, and a is 8 and c is negative 3, which gives you negative 24. Okay, so that is step 1, multiplying a times c. Step 2 is to make a list of the multiples of that answer. Okay, make list of the multiples of that answer, negative 24. Okay, so let's do that. Here's my list. Negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6. Those are all the possible combos of multiplying to give me negative 24. So the next question is, or the next step is, which of these pair of numbers is, when you combine them, will give you the middle value, negative 10. So if I combine these, this will give me a 23. That's not a 23. If I combine these, that'll give me a 10. That's great. I have a 10, but I want it to be a negative. So I have the right number, just the wrong sign. So that means that right here, I have the right numbers, just the wrong signs. So you would change that to a plus, change that to a minus, and you're good to go. Let's move on to step 3. Now, step 3, one option is to change your trinomial to a polynomial by changing this middle term, negative 10x, to become positive 2x minus 12x, creating 4 terms instead of 1, 2, 3 terms. That way you could apply factoring by grouping, but that's a whole other 3 or 4 steps in itself. So the shortcut, the fastest way that I taught you was to set up this, where you had ax plus a number times ax plus a number, all right? So what is a? A is 8, so you're going to set it up 8x, and what goes right here, what numbers go right here? Well, the numbers from step 2 go right here. So I have a plus 2, and I also have a minus 12. Okay, so that was step 3, nice and easy. And step 4 is to magically divide each binomial by whatever you can. Okay, it's not really pulling out a GCF, it's actually just magically dividing it, right? So we know that this is not the correct factored form because 8x times 8x is not 8x squared. That would give you 64x squared, which would be wrong. So this is why we have to do that 4th magical step of dividing this binomial by what? By 2, because they're both numbers are divisible by 2. And over here, yes, I could divide both of them by 2, but I'm going to go for the biggest value you could divide by, kind of like the greatest common factor. You're going to divide both of these by 4. So if I divide both of these by 2, 8x plus 2, when I divide them both by 2, that'll give me a 4x plus 1. And when I divide these by 4, that'll give me 8 divided by 4 is 2, and 12 divided by 4 is 3. So this is the correct answer, and I hope we understood that last step where we divide this binomial by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. 8, and on this one we could divide by 2, but you got to go for the greatest value that you could divide by. 8 divided by 4 is 2. 12 divided by 4 is 3. Okay, so that's factoring. The more you practice, the easier it will get. And you could have done it with a longer method, but this is the fastest and best method. Another question where your a value is not 1, and the very first type of factoring you should attempt is the first type of factoring that we learned, pulling out the GCF. You see a 4, a 12, hey, I could pull out a 4. Wait a minute, you can't pull out a 4 from 9. That would have been great if this was an 8, but no, you can't pull out a GCF. Okay, so then what? Well, we have a number out here in the front, so yeah, I could do that multi-step process of factoring. However, you should recognize that these are both perfect square terms. So maybe, just maybe, you could set this up, do the square root of the first one, plug it in here, do the square root of the last one, plug it in there, and then think of the signs. So let's attempt this. I mean, it doesn't guarantee you that it's going to work if you have a perfect square term in the front and in the back. But we do have a perfect square term in the a value, perfect square term in the c value. Let's try it. What is the square root of 4x squared? The square root of 4x squared is simply x, 2x, right? The square root of 4 is 2 with an x. And what is the square root of 9? Well, the square root of 9 is 3. So we put it 3 right here, okay? So we just repeat those values, the 2x and the 3. Now, the problem is we need some symbols in here. Is this a plus and is this a plus? Is this a minus and this is a minus? Or is this a plus and this is a minus? Who knows? All you got to do is think about it. Well, we know that we end up with the c value of positive 9. So at the very end, it has to be positive 3 times positive 3 in order for it to be a positive 9, or a negative 3 times a negative 3 in order to be a positive 9. So because this c value is positive, the signs have to be the same. They either have to be a negative times a negative or a positive times a positive. Okay. If you look at your middle term, well, the middle term is negative, which means that these have to be minus signs right there. They just have to be. Okay. Why is that? Because if they were positives, if everything was positive, well then you wouldn't have any negatives, everything would be positive. So once again, because your c value is positive, the signs have to be the same. If this would have been positive, then both of them would have been the same plus, but because it's negative, both of them have to be the same minus, okay? And of course, double check your answer by distributing, right? 2 times 2x is 4x squared. 2 times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. Negative 3 times negative 3 is positive 9. Combine the middle terms, negative 6x and negative 6x. 4x squared minus 12x plus 9. And that's exactly the value or the variable expression that we started with. So we know that we factored it correctly. So this is the absolute easiest way to factor this quadratic trinomial, which we could now call a perfect square quadratic trinomial because we know it worked, right? Perfect square term, it did work, okay? Let's move on. Come on, this one's too easy. What do I mean by too easy? Well, there's no number in the front, so that means we could jump right into our factored form format, x, right? Because x times x is x squared. And all we need to do is find the numbers that go right here. So how do we do that? We think what times what is the c value, negative 24, that if you combine together is the b value, negative 11. And I always encourage you to make a list. How could you get negative 24? What times what is negative 24? You have a negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6, negative 5 doesn't work, and that's it. Those are all the possible ways of multiplying numbers together to give you negative 24. Of course, you could use a calculator if you struggle with multiplication. Anyway, which pair of numbers combines together to give you the middle value, negative 11? Well, if I combine 24 minus 1, that's 23. That's not a 23. 12 take away 2, that's 10. That's not a 10. 8 take away 3 is 5. That's not a 5. 6 take away 4 is 2. That's not a 2. Well, what could we conclude here? None of them work. That means that this is simply not factorable. Okay. Answer, NF. You could probably type in not factorable, but you know, on the instructions I'll say type in NF if it's not factorable, and voila, you cannot factor it. Let's move on. Back to it, we have a number out here, so you might be thinking you're gonna have to do the multi-step process of multiplying a times c, but don't do that mistake, okay? The first type of factoring method that you learned was to pull out the GCF. That's the first type of factoring method you should always attempt. Now we have 3 even terms. You could definitely pull out the multiple of 2. Let's do that. Pull out that 2. What's going to be left on the inside? X squared, right? Because 2 times what gets us back to 2x squared? 2 times x squared gets us back to 2x squared. 2 times what gets us back to negative 18x? That'll be 2 times negative 9x will get us back to negative 18x. 2 times what gets us back to positive 36? 2 times positive 18 will get us back to positive 36. So now we recognize that inside the parenthesis we have the a value of 1 and a blue quadratic trinomial, and maybe, just maybe, you could think what times what is a c value, 18, that if you combine together is a b value, negative 9. And I always say make a list. What times what is positive 18? Well, 1 times 18, 2 times 9, 3 times 6, 4, nope, that's it, right? That's all the possible ways, those 3 combos, besides changing signs. Now the question is, if I combine 18 and 1, that'll give me 19. That's not a 19. If I combine 9 and 2, that'll give me 11. That's not an 11. 6 and 3 is 9. That's a 9, but it's a negative 9. So I have the right numbers, just the wrong signs. That means all I need to do is change those signs. So because I don't have a number in front of the x squared, I could continue to factor. That's what we're doing here. And we're going to use that pair of numbers, the minus 3 that goes right there and the plus 6 that goes right there. And there's a GCF of 2 that we originally pulled out. So this is the completely factored form of the original, okay? So don't make the mistake of doing that multi-step process of a times c and then thinking of the multiples of that answer and then changing it to 4 terms, factoring by grouping, or using the shortcut. That's all a waste of time. If you do step 1, pull out the GCF, and then just simply factor that quadratic trinomial in the middle.